And that brings us to the main topic today, which is Newton's 3 laws of motion. These are pretty famous, especially this first one. An object at rest will remain at rest, and an object in motion will remain in motion unless acted on by an unbalanced force. And I like this term unbalanced force because it goes back to what we've been using and talking about. I think external force or outside force, those are fine, but I don't think they're quite as descriptive. So really what we're looking at here is that unbalanced forces cause acceleration. If an object is accelerating, it's because there's an unbalanced force. If the forces are balanced, then the object will just keep doing what it's doing forever. So for example, when you roll a ball, it doesn't actually go on forever because there's friction, an unbalanced force. If you threw a ball somewhere where there was no friction, it would just go on forever and forever. This is known as the law of inertia, right? Objects want to keep doing what they're already doing, and that's what inertia is, the tendency of an object to resist a change in motion. Let's take a look at how inertia can show up in the real world. Obviously, this is a bit of an exaggeration, but when you're in a car and something causes you to stop suddenly, the tendency of the objects is to keep doing what they're already doing. An object in motion stays in motion. So if you're not wearing a seatbelt, your body is going to continue forward. That seatbelt acts as the force to slow you down. Otherwise, you can smash through the windshield and have a very bad day. So I use that term inertia. What it's defined as is the property of an object to resist changing its state of motion. How much inertia an object has depends on how much mass it has. The more mass of an object, the harder it is to move or stop. And this is inertia. So if you look at this example, we've got a large truck which would have lots of mass and hence lots of inertia, and so it would be harder to start moving, but it also would be harder to stop moving. The more inertia something has, the harder it is to start and stop. So let's take a look, make sure we're understanding this. Say you've got good old Ben Too Close is being chased through the woods by a moose. If he makes a zigzag pattern, he might be able to escape by using his low mass and the large mass of the moose to his advantage. This would work because it takes a greater force to accelerate and decelerate the moose because of its larger mass, and so it's harder for it to change direction. There's also some problems you could do with this. For example, a car driving along the highway at a constant velocity. Find the weight and the friction if the engine produces a force of 2,000 newtons between the tires and the road, and the normal force on the car is 12,000 newtons. So really what we're looking at is finding the balancing forces because of this term right here, constant velocity. So if the engine is 2,000 newtons, then friction must be 2,000 newtons. Why? Because it's at a constant velocity, so the forces must be balanced. And since the normal force is 12,000 newtons, the weight must be 12,000 newtons again because of this word right here, constant velocity. One last concept check. Mr. Wegley spent most of his Sunday afternoons at rest on the sofa consuming large amounts of food. What effect does this have upon his inertia? Right? So eating a lot of food will make you gain mass. More mass gives you more inertia, and it's going to be harder and harder to get Mr. Wegley off the couch.